Thank you all for coming this afternoon. One of the challenges of the weekend, the Board of Visitors weekend, is to find novel, interesting things to do late in the afternoon before the reception for the dinner. The last 2 or 3 years, the problem has been solved by our good friend Wayne Rosing. A couple of years ago, we dedicated the Wren Macario accessible telescope, or the wheelchair accessible telescope, out at the visitor center behind us, and if it's clear tonight and you're here, I recommend you look through that. It gives a spectacular view. Wayne provided that, and then last year we dedicated the first of the Las Cumbres Global Observatory Global Network telescope, which was up on Mount Forks. I hope if you've not seen it, ask someone to point it out to you. Wayne wasn't here, but we had he appeared by video, I recall, and we had a delightful talk by Andy Howell. I knew it was Andy, and I was just getting to the Howell. One of our graduate students who worked with Craig Wheeler on supernovae and is doing splendid things at Las Cumbres headquarters. And then this year we have an equally or a more delightful occasion. We're dedicating the Alan Chow telescope, and hope you picked up the program guide for that. And I think Alan's going to talk first, is that right? And then Wayne is going to follow him, and then Tom is going to say a few words in closing, and then if it's dry, we're going to go outside. And the tradition, starting with the first telescope that I think Wayne provided for Bill Wren. Is Bill here? Yes, Bill's over there, which was further up, which was on Mount Lock, which was similar to the wheelchair accessible telescope, and with Bill looked for supernovae and found some supernovae. And I think the stomping of the jalapenos started with that, then it continued with the Monet telescope, and then we've continued on, and we shall hopefully we'll find some volunteer to brave the rain if necessary to continue the tradition. So with those words, let me introduce Dr. Alan Chow. Turn
up the lights a little bit? As time goes on, your pupils become smaller and smaller. And appreciation for dark skies doesn't start until about at least 45 minutes after you turn down the lights. So what I thought I'd do is tell you a little bit of the history of our telescope. It actually spans 30 years. Before I do that, you may want to know a little bit about myself. I'm a let me turn this up. Just press blank. Just press blank. Oh, towards the screen. Okay. Mm-hmm. All right. I'm a eye surgeon, ophthalmologist. But I was very interested in astronomy from the time I was in about the 5th grade. I was in New York. We had immigrated from Hong Kong, and as a school field trip, our 5th grade teacher, Mrs. Ross, took us to the Hayden Planetarium, all right, and the American Museum of Natural History. And when I left those two buildings, I wanted to be either a paleontologist or a astronomer. Then I found out that paleontologists just starve, and then astronomers or aerospace engineers was pretty good, and I was thinking I'm going to go to MIT and build rocket ships to Mars. This was 1969 when NASA laid off all those aerospace engineers and Boeing laid it off. So My father showed me a Wall Street Journal article to that aspect, so I thought, well, I'm still interested, but maybe I need to find a job. So I attended the University of Chicago, but I never lost my interest in astronomy or in engineering. And so I studied medicine for a while. I studied general surgery, studied pediatrics. I ran emergency rooms for a number of years. Actually ran a storefront clinic in Indianapolis for the indigent for a number of years. Eventually I went into ophthalmology, and this gave me an opportunity to do some engineering, which I was just thrilled to do. In ophthalmology, we have a lot of patients who are losing their vision, who are actually blind from degeneration of the retina. And there had been no treatment for it. So when I was at Johns Hopkins, this is back in the early 80s, I thought that perhaps we could develop a artificial retina based on a computer chip that we could put underneath the retina. And so with my brother, who's a semiconductor engineer, we developed this over the years. And this is what you're seeing over here. This is one of the very thinnest MEMS type processing chips that functions. It's less than 1/3 the thickness of a human hair, and about 2 millimeters in diameter. On its surface are thousands of microscopic photodiodes, which are like solar cells, with their own electrode on the surface. And when this is placed underneath the retina and incident light hits it, it produces a charge on the surface of these microphotodiodes, which then stimulate the retina. So originally our intention was to stimulate the retina and create a pixel by pixel type pattern, like what you see on your computer screen. And so in the year 2000, we obtained FDA approval to implant these devices. And yes, we did see patients who were blind seeing phosphenes, but in addition, these devices start stimulating the retina to produce what's called neurotrophic factors, which actually started turning back the clock. These patients are starting to get back the vision they had lost, color vision, visual field, visual acuity. And so about this time was also when I was trying to get this telescope project going. So we were kind of balancing all of this. Now, let me see, right. We implanted these in collaboration with a number of universities, University of Illinois, Rush University, Johns Hopkins, and Emory, between year 2000 and about 2004. And if any of you remember, right about that time, there was quite a bit of excitement. We were on Good Morning America, Dateline. In 2002, President Clinton talked about us in his State of the Union address, but claiming credit for being able to fund this. It was kind of like Gore claiming credit for the internet. So that was quite interesting. This is just a video of this implant in this inserter. We actually go inside the eye, underneath the retina. You can see the implant. It's placed into the subretinal space. The retina then falls over the implant. There's nothing that's required to seal the wound, no laser, and the implant just functions whenever light hits it. Now, I actually had the video of the operation, but I thought people would be too squeamish, so I decided not to show that one. When I showed it, I thought it was really neat. My son's fiance thought that's really neat. My son went, "Oh my gosh!" So anyways, these are the implants in a number of patients, and it's been close to about 8 to 10 years later. Many of these patients are still seeing. What was interesting is that some of these patients were getting what we call the Rip Van Winkle syndrome. They had not seen their own faces in years, sometimes 20 years. And when they saw their faces again, then we thought they must be just so happy. The response was the opposite. They were so sad because they remember what they looked like 20 years ago. They my God, it looks so old. So, in fact, I think Saturday Night Live did kind of a skit on us when this was public. They had Stevie Wonder, who wanted one of our implants, and they had some guy mimicking Stevie Wonder, and I think he supposedly got his vision back, and he looked at his wife and he says, "Woman, what happened to you?" So that was the implant. So that's the other thing I do. I'm an assistant professor at Rush University, and we're hoping to move this forward. I do have to tell you this because we've been on a John Stossel show talking about this. We spent $50 million, and we got through the phase 1 and phase 2 of the FDA, and very excited about it. They actually approved us for the phase 3 of the FDA. which is the final phase before this is available. But they made the study so big, it would have cost us about $200 million. So in this day and age, that was not possible. So right now we're trying to raise funding for what's called humanitarian devices exemption, which we think we can get by a little bit less expensive. So keep your ears and eyes peeled. You may hear more about this as time goes on. So this is what I do. Okay. Many years ago, when I was starting thinking about building a telescope, this is back in the 80s. If you wanted a sophisticated telescope, not a celestron, you had to design it yourself. In this case, we actually had to make it ourselves. We had come up with a design for a Maksutov telescope, and if you remember back in the early 80s, the only one with a Maksutov was Questar. They had a 12-inch Maksutov, which was like, I think it was the cost of a house. So we decided we were going to design our own with a secondary mirror that was separate from the corrector, so we would have even better correction, and this was going to be a flat field device. So no one made any components for it, so here you can see us, we actually did our own casting. My father, I think this was illegal, he took the main feed into the house, the main gas feed, ran into a blower, and then created a fire brick barrel here, and then we basically melted aluminum ingots. You can see over here. And you can see the molten aluminum. This is myself and my father. And we had sand casting facilities, and we basically poured this. Now, when we started this actually in the basement, but the first pouring, it actually broke some of the sand, so the wooden mold started burning, and my mother forced us out into the garage. So that's why you see us over there in the garage. Okay. So now at that time, we thought, well, you know, we're going to go through this route, we might as well develop a company. So I actually formed a company called Chow Skinner, and this is the 11.5-inch Maksutov. At that time, we're thinking of putting on a buyer's mount, so you can see the system. This is actually in Tucson. This fellow was named, a fellow by the name of Bill Anderson. He actually worked on the Kitt Peak telescopes, the large Nodal telescope, and the Hopkins telescope. And so this was, we actually created, this was, again, this is all fabricated from our castings. And so this was an 11.5-inch Maksutov. At that time, the big thing was having a wide, flat field. And so this was capable of exposing, I believe it was 4x5-inch film. So feeling empowered, we thought maybe we would go a lot bigger. So we designed a system of flat field Schmidt. At that time, this was before CCDs. If you want wide field, you have to image with a large photographic plate. And so this was designed as a flat field Schmidt, and you could see some of the Eridis diffraction patterns. It was really quite good, but this is back in the 80s. We found out that it was not so easy. No one made the blank that was of the size that we could use. The machining was difficult, and initially we even had to make our own oven to melt the glass. And you could see some of the early iterations of the tube assembly that didn't work. Eventually, I don't know how much we spent making the oven, but the oven, we could never quite get the consistent temperature control. So that's what you had to do when you were an amateur astronomer many years ago. But eventually, we were able to fabricate the tube many, many years later. Here you can see this tube assembly for the flat fuse Schmidt with the two access ports for the secondary, the primary, the back plate, and the focusing assembly. But by this time, it has become obsolete. So that's what happens when it takes too long to fabricate instruments. So we had, if you look, let's see, down here, this was the original mount that was designed and built by Byers. It was a Byers Series 3 mount. The scope would have been about this size. We realized that this mount was really way too small. And so we waited another number of years, and Ed Byers said that, you know, Alan, we should really have a larger mount. So he actually made 3 Series 4 mounts, one for himself, one for NASA, one for us. And you can see the size difference between the two. And so at this time, this is all just, I could believe, like synchronous motors or just servo motors.
Just a simple synchronous motor.
Right. And so that was created. I had the mount, but no telescope, no, no optics, nothing. So we waited a number of years, in the meantime, he made these cameras. So back in those years, before CCD devices, if you want to shoot photographs, you had to use these plate cameras. This is an 8x10 plate, weighed a ton with an off-axis guider. So again, by the time we got to the point of frustration in the mid to late 90s, this was all obsolete. So Ed Byers referred us to Wayne Rosing. That's how I got a chance to meet Wayne. And I think, even though he didn't say it, he probably was shaking his head. This is never going to work. All right. So that was our association with LCOGT. And over the years, Wayne made a number of modifications and basically turned what was a very antiquated system into a modern instrument. And I cannot thank Wayne and Dorothy enough for the assistance. Without their assistance, this project would never have gotten off the ground. In addition to thanking all those at the University of Texas, the McDonald Observatory, and all the assistance from others. And so this was, so about 2 years ago maybe, during this time, also Wayne was recruited to go back to Google. So one day I think I got an email from Wayne. He says, "Alan, I'm sorry I have to tell you everything is going to be put on hold, but I've got to go back to Google." And so Wayne was at Google for a number of years. After he left Google, he proceeded with working the instrumentation. We decided that the old flat view Schmidt just was not going to be proper. I mean, astronomers were not using flat view Schmidts anymore. So with Wayne's help, we secured a Arcos Ritchie Cratchit 24-inch, and he mounted it on, as you see over here, on the Byers mount. But Wayne will tell you about some of the modifications he made. Well, this is about 2 years ago. I remember seeing this in Santa Barbara, and I thought that, boy, this would be so inappropriate to be in my backyard. I'll show you this. So these are some of the modifications LCOGT made to the telescope, including at one point where he even tested a multi-instrument rotator. And Wayne and LCOGT made custom vanes which protected the scope. So this is my backyard over here in Chicago. You could see, I think we could see about 10 stars on a good night. And so this is compared to McDonald Observatory. So we decided it was just inappropriate to put a scope like this there. And so I asked Wayne if he knew of someone that would benefit from a scope like this. He said, as a matter of fact, yes. And so that's how we were introduced to McDonald Observatory. So that's basically how the scope got here. And I'm so happy that it is here. Thank you. Wayne will now tell you a little bit about the capabilities of the LCOGT modified Ritchie Cratchit.
Thank you, Alan. This has been almost the longest running project I've ever done. The longer running project is LCOGT, Las Cumbres Observatory Global Telescope Network. Now, I need to explain that. Las Cumbres is a community west of Los Gatos near San Jose, California. It's called the Summit. It's a 120 family conservation cooperative. Everyone has an acre. There's 1,200 acres in common. We all live there. And at that time, I lived there in 1983, and I got this idea that you could build small telescopes, add CCD cameras, make them robotic, put them on the internet, and spread them around the world. And you could observe continuously, or have a number of telescopes available to observe instantly. Now, in '83, there wasn't much, or weren't much, in the way of alerts on the internet for astronomical things. But there were these gamma ray bursts and a few other things, and occasional supernova were being found, and people would want to follow them up. And so this idea formed, and I decided I would do it. But I had work to do in the meantime. At that time, I was at Sun Microsystems. Apple, actually, at the time, and then Sun. And so in between all the work, my true love is astronomy, instrumentation, engineering, software engineering, making all this stuff work. So I've been working on that project for a long time. Then in the mid-90s, I sort of had an interlude where I was between jobs. I sort of retired early from Sun and was doing telescope work, and I was introduced to Bill Wren by Ed Byers, and essentially helped Bill get the first supernova search telescope able to function. And that's where I started coming to McDonald, which I believe was September of 1995. And so I fell in love with McDonald at that time because it was really interesting to come down to the star parties, and I saw, tens of thousands of people a year coming here at the time. And I thought this was just an unbelievable educational facility because people got to experience real telescopes in real dark sky. With all due respect, that's not Hayden Planetarium. It's very different here. So I've been coming ever since and working on small projects with Bill. And then at some point, we decided, when I was late in my time at Google before I left in 2005, that we started, okay, let's get serious with the WMAT and really engineer it right, put it down here and make it wheelchair accessible and really go for it. So we started that project and delivered that a number of years ago. And then the other project on my list was this one, so here we are. We've worked on this project now quite a bit. Vincent Posner is here. Vincent, where are you? He's lurking around somewhere. There he is. Vincent was the chief mechanical engineer on this project. And then David Petrie is right behind him. David is a jack of all trades. He joined us as primarily a tech writer, but he's been on every installation of every telescope we've done and has become a fully qualified telescope technician, amongst other things. And his daughter, Madison, has been interning this summer, and so she's worked on this telescope too. So I want to thank them specifically for that. And I guess I have to thank Rachel and Laura, their significant others, for putting up with telescope people who fly all over the world, work impossibly long hours, and are totally obsessed. And if you aren't all three of those, you can't do this work. So that's what it is. Now, this telescope is really quite simple. You can sort of see what's going on. It's sort of pointing up, this way, and basically it's aligned more or less like we are. It's pointing to the north, just like every other telescope in the northern hemisphere does. This is called a German mounting, and I guess historically, this is the way telescope mountings were built in Germany a long time ago, but it has some interesting properties. Because the telescope's high, you can get under it and you can look through the eyepiece. And that's really convenient for a place like this. If you look at some of the big telescopes here, and particularly more modern telescopes like the HET or even our 1 meter, you discover that you can't get your eye under where the cameras are. You can't even get it. If you're in there, you're going to get chopped up when it moves. So modern telescopes, usually, you don't get to look through. These old German mounts have the advantage of the eyepieces out in the open. So the other problem with them is that you have a big weight out on one side. As you can see, there's a big telescope up there. That's 400 pounds of telescope and camera. Well, it doesn't show on the picture very well, but right here is one black weight. Well, there's actually 4 black weights on the telescope. This was taken just as we craned it in. So these weights weigh, what, 80 pounds a piece or something like that? And there's 4 of them out at the end of a long shaft, and that compensates it. So the tricky part about these things is you've got an enormous amount of weight hanging out in free space, and you got to make it strong. And for those of you who've looked at both of the telescopes up top, the 107 and the 82, you'll notice there's very big, large things hanging off in space. Those are the same corresponding counterweights. Modern designs tend to dispense with that by, you don't have to look through it anymore. You don't have to get a human being near the eyepiece. So this has been automated. When it came from Ed Byers, it had a synchronous motor that basically went around once a minute or something like that, and it had gearing, and that was it. And we basically pulled out the mechanics, we remachined the shafts, we added encoders. The thing can read out to a tenth of an arc second, or basically about 1/12 millionth of a circle. And then we added servo drives and computer control. The telescope can point where you command it to. It can track all night long. It compensates for the atmosphere. And most importantly, with the computers we have up on the mountain near the HET, it can run robotically all night and do observing requests from a queue that people would submit. Now, okay, period, full stop, new paragraph. LCO, Las Cumbres Observatory, now has 9 1-meter telescopes deployed around the world, 3 in South Africa, 3 in Chile, and 2 in Siding Spring, Australia. Plus we have 2 80-inch telescopes, 1 in Maui and 1 in Australia. And then we have 1 meter here, with the intention of adding more 1 meters here. Our 1 meter is up next to the HET. If you go out and look at the HET, you'll see it. And then you sort of see some stuff, some square stuff, and that's the lunar ranging stuff. And then you'll see this one teeny little white something, which is a duplicate of this dome. And actually something we're very proud of. You can go in any of our domes when they're all cleaned up, and you open your eyes and you look, with the exception of this telescope, they're all the same. Everything about them is identical, anywhere in the world. My wife didn't believe me until she came to Chile and she walked in, she said, you weren't kidding. They really are the same. Because that way we get the economy of scale and we can actually manage these things. Well, those telescopes are now online, so we have 9 1-meter telescopes online. Our scheduling software is within a week of operating, and then we're going to be opening this up for a lot of scientific use for both for our people and for scientists all over the world. And then McDonald as a host has a certain amount of time they get, but they get to use that time on any of our 1 meters, not simply on their own. For this telescope, the Chow telescope, the terms of the gift are a little bit different. The concept is, during the star party time, the telescope will be available for standard star party use. And it will just be used by the visitor center staff, presumably, for people to view. And because it's a larger telescope, it'll be able to go fainter for certain objects, and it'll be nicer for certain kinds of things. And a very simple telescope, and the main thing we have to do is get a pad on the counterweights so someone doesn't smash their head on the counterweights, because they're painted black, and guess what? You can't see them at night, which is, I think, a mistake. I think we're going to have a sail cover thing made that's going to be bright fluorescent white, and then I'm going to put a whole bunch of red LEDs like the Star of Texas on the end, so that, you know, it'll be light pollution, but it will save somebody from smashing their head. So that's what happens during star parties. Now, my vision of what happens when the star party's over is you take the key out of the panel and you flip a lazy Susan, so you flip the eyepiece out and the camera in. At that point, a little green light goes on. You take the key out of the panel, you go to the door, you close the door, the red lights turn off at that point. The little green light goes on the outside door, says everything is good. You take the key and you put the key back wherever Frank wants to have the key put. And then the telescope becomes a robot and spends the rest of the night observing whatever is in its queue. And the idea is that the McDonald and the visitor center people and the education folks in Austin will over time fill up that queue with observations from schools, from teachers, from whomever. And so from our point of view, we're not thinking of this as another LCO science instrument. I was very interested in, and my wife was too, that this one, we're going to keep those pesky scientists off of it, as I say. This will be for education. Now, I somehow suspect the scientists may play with it, and that's fine too. But hopefully they'll involve some kids in it. So this is the start of a worldwide education network. We have 24 small 16-inch telescopes that we expect to deploy over the next 3 to 4 years all over the world. And those will be dedicated to education. And this will be the flagship first one of those telescopes. So I want to thank Dr. Chow for being the most patient customer on the planet. The amount that I charged him for this project is so lost in history, I don't even know what it is, but it's an incredibly small fraction of what it cost. But that's fine. It's here now, and I hope that the world will enjoy it. I'll just say in closing, what's phenomenal about McDonald is this visitor center, the public outreach that happens here. There's almost nowhere. I don't know how many people come here, 60, 80, I've heard all kinds of numbers, but we'll just say 60, 70,000 people have contact every year with a real science facility, real telescopes, dark sky, with a staff, visitor center staff, who sits out there on those cold nights and those warm nights and those wet nights and all those other nights and explains to people what's going on in a competent way. And I think this organization does a tremendous amount for science and for science awareness in our country. And that's why I'm so enthusiastic, and that's why we wanted to give our part of this project to make it go. So I want to thank McDonald and the staff, the directors, and the board of visitors, who I know you guys all help support this thing. It's a fantastic effort. Probably, in my opinion, the finest effort I know of in the United States having to do with astronomy outreach. So I thank you.
I'm Tom Barnes. I'm the superintendent here at McDonald Observatory, and I think it's become a tradition that I get to do the thank yous for these projects. And I love doing that. I read once someplace that that when people work on something, that the recognition of the excellence that they did in that project is more important than the salary they got. At least that's what I tell my staff. But all kidding aside, I believe that's true, that if we don't thank the people who did the work, we are remiss in completing a project. So I'm going to say thanks to the folks who prepared this project. I don't know all of the people, or I don't know most of the people who worked on this at Las Cumbres Observatory, so please bear with me if I misstate their names. And you all be patient. I've got about 7 transparencies. They're full of names, and I'm going to read them all, because I think those folks deserve that. A little bit there's the historical flow here. The telescope, as you know, as you've already heard, comes from Dr. Alan Chow and Wayne Rosen. You've heard how it came to be and how it came to be changed. It's a 24-inch f8 Ritchie-Chrétien telescope. It's owned by Dr. Chow, and it was refurbished at Las Cumbres Observatory under the direction of Wayne Rosen. Then, as Wayne said, and as Alan said, there was a decision taken to bring it to McDonald Observatory that involved a number of people. Wayne, Alan, Sandy Preston, Bill Rand, Frank Cianciolo were all involved in promoting the location of this facility here. It was chosen because of excellent observing location, both for Dr. Chow to access remotely, and because it would provide an excellent new telescope for educational and public outreach for McDonald Observatory. So there were negotiations begun in March of 2010. And I have to say, we're part of a state university, so there's always negotiations that take place. So Alan agreed to a 5-year loan. Sandy Preston, Dottie Fraish, and John Martinez of LCO drafted an MOU, a memorandum of understanding between, amongst the three parties. That first draft, according to my records anyway, showed up in March of 2010. And then Alan, David, and Wayne approved the MOU because they're the signatories to it. And that was signed in April of 2011. So you can see it took about a year for the bureaucracy to take place. But we didn't wait for that to get started because it was clear that we were going to reach an agreement. It was just a matter of when it was all the T's were crossed and the I's were dotted. So Daniel Heath managed this project on behalf of the University of Texas at Austin in terms of preparing for the arrival of the dome and the telescope. That was our part of the project, was to have everything ready so when the dome came and the telescope came, they could be integrated and work. Sandy Preston coordinated the work from the McDonald side. John Martinez and Mike Filarski coordinated the work from the Las Cumbres Observatory side. Stuart Cross and Rex Barrick, who's now retired, managed the interactions with the contractors on site. Here is an early drawing showing where the telescope would go relative to the amphitheater, the Ren Macario accessible telescope, and 2 existing telescope domes, and of course we're seated right in here. AECOM was the contractor chosen by the University of Texas to manage the site preparation, and that was Colin Brownlow, and they did the civil and structural engineering required for the preparation for the dome. Now at Las Cumbres, there was a lot more going on, as you can see from this slide. Telescope and observatory systems engineering took place there. I'm going to read all these folks, because I think they deserve it. Observatory design, manufacturing, and installation, John Martinez, Jim Bauman, and Enrique Estrada. The electrical and mechanical commissioning, John De Vera, Eric Nelson, Dave Mullins, and John Hegeland. And then in software engineering and systems design and development, Eric Hawkins, Zach Walker, Ben Burleson, Martin Norbury, Eric Saunders, Mark Bowman again, Martin Ford, Dave Petrie, and Steve Foll. Now, I recognize a lot of these names from the Las Cumbres Observatory dedication a year ago. Information technology and communications, Brian Hayworth and Gary White. The optical tube assembly came, as was said already, from RC Optical Systems, and the mount, Edward Byers and Company, Inc. The telescope was then refurbished, as you've heard already, to prepare for this particular mission. Modifications to the mount, to the optical telescope assembly, the instrument stage, Vince Posner, Val Gorbanoff, John Martinez, Nico Ruvalcalba, Scott Cook, Will Haynes, Rachel Haynes, David Petrie, and Ann Hillstrom. The electrical work in the refurbishment was Wayne Rosing, John De Vera, Rich Lobdell, Eric Nelson, and Dave Mullins. And the general assembly of the refurbished facility is Val Gorbanoff, Scott Cook, Vince Posner, John Martinez, Madison Petrie, and Wayne Rosing. And then the machinists who worked on it, Richard Green and Stefan Hausler. The telescope final configuration, the installation and engineering commissioning to make it all work at Santa Barbara were Wayne Rosing and David Petrie. Remote assistance on site was provided by our own Bill Wren back there. Purchasing, Alan Kuznick, and Shipping and Logistics, Chester Gilmore. And here you see the telescope as it was being integrated in Santa Barbara, California. Meanwhile, we had about 6 months of work to prepare the site to receive the dome and then later the telescope. So here you see the pad being poured, here you see the dome being located on the pad, and then you see the completed site with the dome ready to receive the telescope. Keystone Contractors and Engineering, led by Francisco Gillian, did the civil and concrete work. Warden Construction, led by Sherry Snowden, and Mike Weathers handled the electric. Mike Weathers is out of Alpine. And then Stuart Cross, Rex Berrick, Alonzo Adame, Danny Basin, Rodney Cantwell, Kelly Glines, Raul Hernandez, Kevin Teague, and Chuck Rudder, all McDonald employees, assisted the contractors in accomplishing this work. And then Coyne Gibson and Darren Crook installed the fiber optics that connected this telescope to the network.
Tom, two names that we forgot to, I should have told you about, are Joe Wheelock and Rachel Fischel provided a very good north-south line.
Thank you. I'm sorry they're not on here.
Thanks
Thanks
for
to
checking and rechecking that.
A very good north-south
Dead
line.
on.
Thank you. And then the telescope was installed not that long ago. You see here, these names go this way in the picture. You can see it being lowered in through the slit of the dome. Stuart Cross, Dave Petrie, David Hensel, Danny Spencer, Kevin Teague, Raul Hernandez, Kelly Glines, Wayne Rosing, and Bill Wren installed it into the dome. And then Wayne and David Petrie did the commissioning of the telescope to make sure that once it was in the dome, you could point it and reliably find something. This dedication ceremony, the project's not complete until you dedicate the telescope. So the dedication ceremony was organized by Sandy Preston. Frank Cianciolo took the photographs that you see, the beautiful photographs that are on this handout. And Leslie Ernst designed the booklet that you've been handed out. It always takes money. So there were donors who contributed either time and expertise and money to make this possible. Wayne Rosing and Dorothy Largay, Leopold Tedesco, the Frank and Susan Bash endowed chair for the director of McDonald Observatory. That's a long way of saying David Lambert. And the Las Cumbres Observatory Global Telescope Network. They all contributed to make this possible. But mostly, we want to say a special thanks to Dr. Alan Chow for the loan of this spectacular telescope. So thank you.
I would like to say that even though our memorandum of understanding is for the loan of the telescope for 5 years, I believe there was a clause in there that after 5 years, I can take the telescope out with me, only if I can carry it on my back.